So today we are going to learn about shift registers. 74194 is the IC, and again this IC is simpler to recognize because only one notch is there. There is no circle, so this becomes my pin number 1. So now what you have to do is open your 0 insertion 4 socket, place it properly. Now one thing to remember that this particular IC is 8 pin IC and not 7 pin. So your ground goes to pin number 8 instead of pin number 7. So let us connect that first. The simplest connection. First you choose last pin, that is pin number 8, and put it to ground. Next connection what you have to do is VCC, that is at pin number 16. So you connect it to the VCC. These two connections are there. Next is the clear bar. So we don't have to clear anything from this IC. If you want, we can connect it to one of the inputs, but right now I just put it clear bar. So when this is low, then it will clear all the outputs. So I will just put it to VCC to ensure that nothing gets cleared. Next is, now this is a shift register. So what it will do is take the 4 inputs A, B, C, D, and when we apply the clock, these 4 inputs will be transferred to the output QA, QB, QC, QD. So that becomes parallel in, parallel out operation. So for that I need to connect 4 wires. Let's start with 0. Now this 0 I will connect it to A so that visualization becomes easy. So that is pin number 3. So this is my first input, and similarly I will connect others, that is pin number 1 from this kit goes to QB over here. Then next is pin number 2 goes to QC. So fortunately they are in line, so there is no problem. Just 1 2 3 4 directly connects to other 1 2 3 4. Next is this particular IC also has serial in, serial parallel out, or serial out, whatever you say. So all the options are there. So if you want to give input from right side, you have to connect your input at this. So whatever bit input you give through this particular pin, that you will see on the output. So what I will do is I will connect this to another input. Now this becomes my right input. I am connecting it to pin number 4, and then next is left input, that is at pin number 7, that is I am connecting to pin number 5. So now these are the parallel inputs, and these two right input and left input. So right में भेजेंगे, so it will go from this to this. Left में भेजेंगे, so it will go from that. Now I want to see the outputs. So next thing is I will connect 4 outputs. They all start with immediate pin below VCC, so QA. Now as we follow the tradition, 0 will go to QA or A, so I will put this to 0, and all 4 are straight. So 18 will be QB, that will go to 1. Next will be QC, that will go to the next pin, and ensure that you just turn off the circuit when you are doing the wiring. And finally here QD goes to the 4th output. So this is all outputs. Next thing you need to connect its clock, so that is pin number 11. Now here you can connect the clock to the pulsar so that you get a control over the clock, but later on I want you to see it with 1 Hz signal so that you will see that shift properly. I just give it to pulsar. Next is most important bits, S0 and S1. These are the select bits that allows you to select which mode this shift register should work in, whether to work in, parallel out, or right shift register, that is serial in, serial parallel out. Even you can have serial in, serial out if you take output from QD. And then you can also have left shift, that is first serial in and then either parallel out or parallel single out, that is serial out. So let us connect these two. So as we expect, these two should be controllable, so you need to connect them to the inputs. So again, this is a 8 pin IC, so in front of 8 this is pin number 9, but because of this configuration this shows 13. So this goes, and here we complete the wiring diagram. So let us see the working of this circuit now. So initially all four are zeros, even modes are zero, everything is zero, and you don't have any output over here. Now let us set one of the bits to high, and now here you have to understand the modes. So when both are low, it will maintain its previous state. When both goes to high, it becomes parallel in, parallel out. So A, B, C, D, that is 0, 0, 1, 0 will get transferred to the output once I give the clock. So now I would like to give the clock and show it to you how the output gets transferred, and it should have worked. There is some connection error, let me just check. So I forgot to make the mode spin high, and now if I give the clock, it got transferred. So now let us see the next operation, that is one left, S1 low and other one is high. So let us do that here. Now since this is 0, 0, you will see 0 get transferred through all four and your entire line will reset. So I will just click now clock and it got reset. Next thing is I will put both of them to high, and now if I give a clock, it got shifted so fast that you couldn't see it, so it all become 1 immediately. Now if you want to see this moment, what you have to do is you have to first invert the connection, and then you can give the clock from here where you can get a 1 Hz signal. So what that we need one of the inputs to be high. Now it is in mode 2, and now if I turn, you can see that it went out. Again I will show it to you. This is in mode 2. I will just make this bit also high, so now you can see the shift, and these two bits